In this video, we'll be talking about velocity and the position function. A position function is used to give the position s of an object moving in a straight line at any given time t. The position of a free-falling object under the influence of gravity, either 32 feet per second or 9.8 meters per second, that position is represented by the equation s of t. Notice s is your position, t is your time. S of t is equal to 1/2 times the gravity times t squared plus v sub 0 t plus s sub 0, where g is our force of gravity, either 32 feet per second squared or 9.8 meters per second squared. T is the time. V sub 0 is the initial velocity, or the velocity at time 0. And s sub 0 is the initial position, or the position at time 0. Average velocity is given by the change in s over the change in t, and the instantaneous velocity, which we'll call v of t, is equal to the derivative of s of t, or the position function. So our position function is given here, and then our velocity function is the derivative of that. Our problem is, a ball is dropped from a height of 100 feet. Its height, s, in feet, at time t in seconds, is given by the position function s of t is equal to a negative 16 t squared plus 100. Notice that this is our half of the 32 feet per second squared. So the negative 16 is the half of the gravity constant. Find the average velocity over the time interval from 1 second to 2 seconds. Alright, we already noticed that this was the 1/2 g of our position function. And also, since our ball is being dropped, this means then that our initial velocity is 0 because it's not being thrown, it's being dropped. So that's why we don't have a t term in here between the t squared term and the constant. So for our average velocity, we just need the change in position over the change in time. This is average velocity. So we're going to need to find our position at each of these times. When t equals 1, s of 1 will equal negative 16 times 1 squared plus 100. And that is 84. When t is 2, s of 2 is negative 16 times 2 squared plus 100, and that is 36. So our average velocity will be the change in our position. So 84 subtract 36 over, and then the change in our times would be 1 minus 2. This gives us 48 over a negative 1, which means our average velocity is a negative 48 feet per second. Now this is negative because our object is moving downward.